Why don't we start off by introducing Cockroach as well? Like the first question I get asked by clients, by my colleagues is, what's with the name?
Yeah, that's a good question. That's what the Indian customs agent asked me when I came into India last week. So the story kind of begins with our founders, Peter, Spencer, and Ben. They'd all worked together at Google on things like Colossus. They went off to found a new company, and they had the startup, they were building a product, and they were frustrated with the data solutions that they were working with. Their secondary indexes, resiliency. They wanted to use the tooling that they had loved and been productive with at Google, like Spanner. So they lived in New York at this time. They had moved to New York, and they started building a database, and they were looking for a name that signified the values that they wanted their database to have: resiliency, scale, thriving everywhere. And as in New York, and I'm sure in most large city, there's a venerable insect called a cockroach, which is all of those things. So they called it Cockroach Labs, Cockroach Database.
Interesting. So it's one of those, I think, organisms that can even survive a nuclear attack. So, yeah. Tell us a little bit about, a lot of us here use Postgres and other databases. Like people, like just show of hands, how many of you have heard of Cockroach?
Well, that's good. Yeah.
How many are using it?
Raise your hand. All right.
All right, let's start with that question. So we all know, at least like I saw 50% of the hand go up. We all know what Cockroach is. Tell us about what are the initial struggles like clients, your customers in your engagement, they go through when they want to adopt Cockroach DB?
Sure. I think it's interesting, like a single region database, like a single node database, or even a single region database and a multi-region database, they seem very similar. And you can actually, in most cases with Cockroach, if you've built your application using Postgres, you could get it running without it really changing anything. The problem is, as you start to add scale to it, things start to happen. And so syntactically, they're very similar and almost identical. The way they run, the performance characteristics, the scalability and resilience characteristics, can be very different. So for example, we've seen clients, they get their database, they've been running in a single node or in a single, over a couple of AZs. They'll spin it up, they'll put up a cluster, or they'll put up some nodes in, let's say, Tokyo, put up some nodes in New York or the US East, and then they'll put up something, let's say, in India. And then all of a sudden, a database that performed well really starts to grind to a halt because they're doing joins, for example, across regions. And speed of light, unfortunately, we haven't been able to optimize that away yet. So with customers, I think when you start to make this change, you really have to understand your workload. What are the things, what's the data that's kept together? What's the data that's going to be spread apart? And what are the data types and the parts of your database that you can use to take advantage and to exploit the characteristics of your data and your workflow so that you don't have to make long trips for data that's gathered together.
That's interesting. Like whenever I hear such requirements, like people think, okay, I can do that with my key value store, right? It's probably good, but that's a very narrow choice because a lot of us have gone through this stage where we have this cross DC requirements, cross continent requirements. Maybe I can't use a relational database, but I can use key value, and then you have this problem, right? Like you're trying to model your rich domain into key value, and that doesn't go well. So what's your choice? So for people who don't know Cockroach DB, under the hood, it is a key value store.
Right.
Like, what's your decision to make it a complete SQL for the users?
Yeah, that's a good question. I think SQL and PostgreSQL these days is kind of the lingua franca of data. And I've been at Cockroach for 5 years, so databases are very hard to build. So I don't want to disparage key value stores by any means. Key value stores are really good at storing data, right? Key value, get a key value, you put it in. But I think for a lot of workloads, just storing the data is just like 1/10 of what you need to do with it, right? It needs to be clean. For people, I'm sure, here running tons of machine learning, AI workflows, my experience is that the rule of thumb that 90% of your time is spent cleaning data is true, right? But A relational database can help you with that, with constraints, with foreign key constraints. But especially in an OLTP database, usually you write data, but then you fetch it a lot more. Like, how easy is it to get the data? You need to consume it. And I think nothing right now really surpasses SQL at providing that at scale and across a wide application base.
Yeah, thanks for that. So I want to change the gear a bit and talk about usage. Like, what kind of customers are now using, at least, I mean, maybe in Indian context or even outside India, like, who are your customers and what's their problem statement they come up to you with, get started with Cockroach?
Sure. So I'll cover the problem statement first and give you a typical journey of a customer. Like, what are the triggers to even explore something like a distributed SQL database? Most of the times when companies start off, they don't have that notion in mind that they're going to have magnanimous scale. So what do is they start off with a single monolithic database, could be PostgreSQL, have a master node and a replica node. And then COVID happens and scale happens. So what do you do then? You put a amazing NoSQL database in between, and then you ask that NoSQL database to take all that load and do only the transactional workloads on your SQL database. But this comes at a huge cost, because then now you need to maintain the state between the NoSQL database and the SQL database and deploy some amount of event-driven architecture between them. Could be Red Panda, could be could be Confluent Kafka, any of those messaging buses between them, right? So a lot of time is spent between ensuring the right state of the data between these two, and you are duplicating, triplicating your data all along. One of the things that we really solve beyond scale and resiliency is simplification of architecture. We have seen so many architectures which had 4 components, 5 components, have then moved over to a single database that really helps them scale and in a resilient manner, right? So I would say that if you have triggers like resiliency, if you have triggers like massive scale, today Kiran was talking about how micropayments, every micropayment still needs to hit the core banking ecosystem. No matter how much our beautification you do on your UI or on application side, you modernize your application, you convert it to microservices, the choking point still remains that master node, which is doing your right operations. This is one of the shackles that we are freeing up a lot of customers from. And naturally, we see a huge interest from financial services. For context, we work with some of the top 3 banks in US. Just recently onboarded one large private sector bank in India for their first workload. So financial sector remains a key domain for us. Also onboarded a large broker in India, which had similar challenges. But not only that, we also see very quickly this whole issue transpiring into gaming. India is also a large country with a lot of gamers. All the gamers want to ensure that their game state data is up to date. They want to start the game where they ended it from, so on and so forth. So gaming remains another key vertical, along with e-commerce as well, where we have customers like DoorDash.
I think I'm just going to pick up one topic that you mentioned. When you're choosing, I mean, it is a hard problem to decide, what database to use or what database to evolve to from your existing architecture. You mentioned the word master, like maybe primary, and not a lot of databases are out there that accepts multiple primary or multiple master. All right. Even if I go to the popular services like Aurora, it is still under the hood a single writer database which scales the read operations, right? Talk about a little bit more about what Cockroach has to offer and how Cockroach is like fundamentally different with this whole multi-primary, right? If you have 10 nodes, if I am the client, which is, it's hard to say a client. So if I'm the application server connecting to the database on the backend still, it's still a client for the database. I get to choose to write to all 10 nodes if I have a 10 node cluster. And that's not something we are used to, right? So we are always used to give me one connection string for the writer and then a pool for the reader, maybe on a read replica. Like, what was the fundamental design that went in? Maybe this was inspired by Spanner. Like, could you talk us a little bit more about the choices made?
Sure. I think, definitely. I think Spanner was like the father, grandfather of a lot of distributed systems, and definitely an inspiration for Cockroach. I think one of the things, Spanner had a couple of things that we took a lot of inspiration from, and I think one is in a distributed system. What does that mean? There's lots of different parts everywhere. I think at Google they realized, and that consistency. We talked about key values, and the consistent for an application engineer, having this illusion that you have one node and you're the only person working on that node is a critical productivity boost, and it makes it easier to write correct applications. So, but that's great. But how do you scale? And I think part, kind of what you were leading towards is we took the inspiration of you have your database, all the data in your database, and we build these little primitives. We call them ranges, but each is a consensus group. People may have heard of Paxos or Raft. So basically, you take all of your data and you kind of hit it with a hammer, and it splinters into all of these ranges, we call them, but each has its own little consensus round, which makes sure that it gives you that illusion of there's only one piece of data, no matter where you look. And then you do a lot of work to bring that all back together with SQL, with follower reads, and all these other things to start to work around the latency issues. So, but when you split up into all those pieces, you have, like you said, a choice to make. You're going to privilege one piece, but if you privilege one piece, that can become a scale bottleneck. And one of the design principles, Cockroach, right, wanted to thrive and scale out as much as possible. So we wanted to be as perfectly parallelizable, as horizontally scalable as possible. So we took that requirement of no single writers and then use consensus algorithms and a lot of work to bring back that illusion of one node with you being the only person on that node.
I can't stress this fact enough, right? Like I was watching this architecture talk. It's one of those talks where you had really deep expertise in your SRE teams, and they kind of built this custom horizontally scalable Postgres instances. And they were talking about the design choices and what it means. And then in one part of the talk, and this person says, what happens beyond horizontal scaling, right? Like what happens if you have one customer, you're horizontally scaling your databases, but if one customer is bigger than a partition or a node, you're stuck with a vertically scaled database. What happens then, right? It just struck me that if you go down this path of, I know MySQL, I know Postgres, and I'm just horizontally shard, I will probably collocate a lot of small tenants in one node, maybe give the whole node to my large customer. Like if you happen to go down that path, you better know what you're doing because you would hit on these challenges. And it's really important that you pick a database that solves this for you, right? Because doing this part of horizontal sharding and then finding out how do I join data at runtime, those are hard challenges, right? Like I'm happy a database solves this for me as opposed to me being the architect or an application developer to solve this manually myself, right? So I can't stress the fact that if you have a problem where you need to go past a node, pick a database that does that out of the box for you and don't do manual sharding, right?
So Bharani, that's quite interesting because Spencer, our founder, actually worked on the AdWords project. He was an early member at Google Cloud, at Google itself, the company Google, and he was responsible for managing the AdWords. So there was a point in time when AdWords really blew up. At one point in time, he was doing exactly the same thing, but for MySQL. So I get it that there is a way to scale this through horizontal sharding, but it became so challenging every time scale hit, they had to again manually shard it and shard it and shard it over and over again.
Yeah, I think one of the things we found is total cost of ownership is a very nebulous thing and hard to figure out, but I can't stress enough how much we've heard from customers manually managing shards, schema changes across shards. You become a successful company, right? All of your clients are blowing up. You have this really big client blowing up. How do you split that across nodes? It's a very hard problem. It's a fun one, but it's hard.
Speaking of distributed systems, this is a distributed systems track. Can you share us really hard challenges that you faced? Because like one thing to say that, I have this black box system that solves everything for me, but another thing to actually run it in production. So when you run these in production, like you get to see pretty much all the edges. I think there was this one talk where this architect says, let's say, if you have a scenario that happens 1 in a million, guess the number of days it takes in production to actually bubble this bug up. It's actually 11 days, right? Like in 11 days, you are going to hit that bug because your server time is way faster than the physical time. So tell us any interesting, challenging distributed systems problems that you faced when you are in this journey.
Sure. I think there's lots of them. I think one of the things that's interesting about distributed systems, I think a lot of the core algorithms are very conceptually simple, like voting, right? We all kind of understand voting. We're trying to get that to work in an environment. And public clouds are amazing things, but at scale, networks are partitioning, and they partition in strange ways, right? You can always totally partition. We've all seen that where two AZs no longer can talk to each other. But we've also seen partial partitions where some of the nodes in one AZ can talk to some of the nodes in the other. We've seen anti-symmetric partitions where one node can talk to another node, but that node can't talk back to the node that called it. And so one of the things, so a lot of the work I feel, building Cockroach and watching Cockroach get built is just this fine, obsessive attention to detail. Like looking at all the corners and how this works, and if this fails, and if this fails while this fails, and you're running a schema change, and you're trying to move a range and split it because there's a lot of traffic there, all at one time. It's a lot of details, but it's very fascinating. So one interesting thing, kind of on the network one, is we were seeing all these partitions, but what we noticed was, so maybe you send in a query to Cockroach or a transaction, it hits a gateway node, and that gateway node can then starts to fan out requests to other nodes. Sometimes that gateway node can't talk to a node it needs to write some data, but another node it can then talk to the node that the gateway can't talk to. So right, you get these, so you can often find your way around. It's like in Google Maps, right? When you're trying to get somewhere and you get all these alternate routes. So recently at Cockroach, we put in some functionality to find those alternate routes quickly and then route around network failures. And we put in, I think the previous talk was observability. Observability is wonderful. And you start to see like all the things breaking and routing around these network partitions. It was very fascinating. Yeah.
I was just thinking, like, we struggle a lot with our test pyramid. I mean, we have unit test, integration test. I think testing distributed system is a thing in a different caliber. Like I can imagine, like, tell us a little bit about like, how do you test and how do you catch regression with such a complex system?
Yeah, testing is quality is a big value at Cockroach, and we take the responsibility of holding really serious, important data very seriously. So we spend a huge amount of time testing, and it runs a gamut of some standard practices and I think some pretty interesting practices. So for sure, unit tests, right? You want to write tons of unit tests. You want to write probably more unit tests than any other type of test you have. So we have tons of unit tests. We have something, Cockroach, everything has to be named after a cockroach. So we have something called roach tests. The roach tests are basically integration tests. You spin up clusters, simulate network partitions, simulate all kinds of different things, and make sure that everything's working together. So I think those are pretty standard. We also have something, we do a lot of randomized testing. Is randomized testing something people do? I'm curious by Yeah, cool. We also, so you randomize, in SQL especially, SQL is a vast surface area. So we have a lot of tests that just randomly generate valid SQL statements, and then you run them to see if they compile and they work. There's a lot of correctness tests that generate random SQL tests and make sure that the data you're expecting to get or write actually comes. And then there's something I think that's really cool. It's called metamorphic testing. So the way to think about metamorphic testing is, for example, the sine function. The sine function has a property like sine of 2 pi x equals x. So you find all of these relationships, and then you randomly generate values and test that those relationships hold. And we find huge amounts of bugs with metamorphic and randomized testing. It's one of the big things that have saved us. And then, of course, we continuously run large clusters in very chaotic environments. So We use Spot instances in our test cluster. So we run our database on Spot instances so that, they're always being preempted and you're losing nodes and making sure that the latency stays predictable and the database still runs. So, and we replicate in the database world, there's thousands of benchmarks, TPCC, YCSB. We run those in those chaos environments. And actually, I should have probably started at the very beginning. The best way to have a quality product is to plan well. And so we use, not for everything, but people are familiar with formal methods like TLA+. So we'll use that to simulate algorithms and make sure they're behaving the way we want them to. And then people have probably heard of Jepsen. Jepsen is a great series of tests to run against a distributed database. But it's expensive, a lot of work, but it's fun.
Yeah, it's worth it. So I'm glad they have to test, so we don't have to. I think we have about 8 or 9 minutes, but we should not have a distributed track without talking about CAP. So I will probably ask this question. So are you a CP or an AP system?
Right, so
Or is it wrong to ask that question?
We'll keep consistency and give up. So if you fully partition away all of your, all the people in your quorum, then you wouldn't be able to do it right.
CP. So that's one of the reasons why I think bank would bet on it, because I would rather have the system down than answer wrongly.
Correct.
So yeah.
I'm happy. I work with Society General. So quick question is, we have a lot of challenges with GDPR, and does Cockroach help us with the GDPR compliance, and what do you think about scaling in the context of GDPR?
Yeah, so that's a good question. We see actually a lot of our customers using Cockroach for regulatory data provenance reasons. I think with Cockroach, you have a series of extensions that have been added to the Postgres syntax that allow you to specify and restrict where data goes. So for example, you can create tables, for example, that are regional by row, which is a table that's spread all over the place, but rows that are in certain countries get automatically sent over to those countries and then they stay there. So yeah, with Cockroach, you can divide your data up according to the localities or the legal requirements that govern those data and put those in those sites. And for example, in the United States, gambling is a big thing these days. There's a lot of laws in the United States that data around people gambling and their bets have to be in the state where those bets were made. So they have 40 nodes, 40 regions, one in each state, and then they keep their data pinned in those respective states.
Thank you.
You're almost on time. Can I have one more question? Okay.
Thank you. Like you mentioned, Cockroach is inspired by Spanner. So Spanner, under the hood, the data is replicated though with Google's Fiberlink network system. What powers Cockroach here? Is it the internet, or does Cockroach systems have their own network connectivity?
Yeah, interesting question. Right now, Cockroach can be deployed in different topologies. So you could run in your own private data centers, and we'd use your network topology. In the public clouds, we use the standard cloud networking. So you can use private link to connect to it and things like that.
Thank you.
Okay, I'm sure we may have more questions, but I think time is up. So thank you.
Thank you so much.
Thanks for having us.
Thank you.